Okay, so the first thing we want to do for this problem that we have about male and female, low income, middle income, and high income, I want to talk about, well, this ChiSquare test for homogeneity. And homo is a Latin prefix. And that Latin prefix means what? Does anyone know? Yeah, it means the same. So one key word you can use when you're reading these problems is if you read through it, when it says, suppose you're interested in knowing whether the distribution of income classes, low, middle, and high, are the same. So what I want you to do right now is I want you to underline or highlight the same. Because when you're taking this test, like I said, I'm not going to let you know if it's independence or homogeneity. I want you to be able to analyze this and say, what am I looking for? Because the problem, if you just look at it, just without even reading it, it looks the same, independence versus homogeneity. And to be honest, there's not a whole lot different other than the interpretation piece. All of the calculations are the same as they are for chi-square for independence. The next thing that will be a good indicator, an actual legitimate indicator, that it is a chi-square test for homogeneity, and this will be every single time. It will never fail. If you notice a random sample of 500 males and 450 females were taken, that is 2 samples. When there's 2+ samples, it will always be a chi-square test for homogeneity. Always. So if you're reading through the problem and you see that they only interview 1,000 people, that's 1 sample. Or they interview 500 people, that's 1 sample. But if they make a point to tell you, hey, we interviewed some males, we asked them what their income was, and then we decided to interview some females and ask them what their income was. That's very different. Okay? So 2+ samples is kind of your key. I'm using homogeneity. Another example I use as an AP stats teacher, I may want to analyze, has my distribution changed of who passes the AP exam throughout the years? So I'll find the number of people who get 5, 4, 3, 2, and 1 for 3 years ago, 2 years ago, and this year. And I'll look and I'll see, is the distribution of my classes the same throughout the years, or has it changed significantly? Okay, significantly. And our first part, again, is that tedious part. And I'm going to assign people to do certain ones, okay? Find the expected value. Again, finish strong, guys, with our last notes of your high school career in mathematics. So what I want to do right now is I want to recreate the chart. Male, female, low income, middle income, high income. Now, if you look at the chart, I am missing something in that original chart. What am I missing? Yeah, I'm missing my totals. So I'm going to fill my totals in on the expected, because that's where I really care about the totals when I'm doing expected counts. If you have graphing technology, you can use that. You can use your computer on the homework to find these, but you need to know how to find them by hand for the test. Like I said, I'll give you a chart on the test, and I'll fill in a lot of the expected values for you. You just have to find a few of them. Does anyone want me to rewrite the formula down for expected counts? Okay, it is row total times column total divided by your table total. Okay, so I need to figure out the column total for low income. So I'm going to add 109 plus 192 together. And when I add 192 plus 109, this column total is 302, right? Or 301, excuse me. Next, I want to find the middle income column. So the middle income column is 365 plus 249, and that gives us 614. And then the high income total. So I'm looking over here at this high income column, and 26 plus 9 is 35. If I add across 301 plus 614 plus 35, I'm going to get 950. Now I need to figure out the total number of males by adding across or doing what? Where else can I find the total males? Yeah, in the problem it states that it's 500. And then I'm going to add across again on the female roles, and that's 450. And now I'm going to assign some of you to help me out so it doesn't take as long. Okay? So it doesn't take as long. So, let's see here. Kendra, can you do the red one for me?
It's 158.
Oh, you already did it. Okay, hold on. Let me assign all of them and then tell me. I'm going to have you do the two reds, okay? And then, Sinclair, can you do the green ones for me? Okay. And then let's get a boy who's paying attention, who has a calculator. Nick, do you have your calculator handy? Okay, Nick, will you do the blue ones for me, please? Okay, so again, what we're doing right now, you should be practicing with us just to double check that you can do it for the test. That's next Thursday. I know that's a lot of time from here and there, but I will be annoyed if you come and ask me how to do it and you're not paying attention now. I'm getting it by finding the total row, 500, times the total column, and that will give me this entry right here for male. So if you're wondering how people are doing that because you've been gone, the male one is in the row for 500 and in the column for 301. So I multiply those together and I divide by my table total. Okay, let's start getting the answers. Kendra, do you have them?
The first one I got 158.4.
158.4. Okay, the next one?
323.2.
323.2.
Yeah, I just rounded up.
That's fine. We can round to the tens, that's fine. Who did green?
Oh, I did.
Okay.
18.4.
18.4. That sounds about right.
Yeah, it is.
Okay.
And then 142.6.
142.6. Okay, and then Nick, did you get the blue ones?
Yeah.
290.8. 16.6. Okay. All right, done with the tedious part. Now we're going to go to the null and alternative hypotheses, and I'm going to type these for you so it looks a little nicer. So step 2, state the HO and state the HA. The big thing here is this is where you're going to get off if you pick the wrong test. So because it's the same, your HO is always an is statement still, and your HA is still an is not statement. And again, use that question to help you. So I'm going to underline, is the distribution of income the same for males and females? So we always assume in our null hypothesis that it is the same. So that's what I'm going to type here just so it looks a little nicer. So using that sentence to help us with our writing. HO, the distribution of income is the same for males and females. And then our HA, it's not the same. Now let me talk a little bit about those expected counts after you write down the null and the alternative, just so you know what the expected counts are. The goal in statistics is not just to be a number cruncher, but to actually know where these numbers are coming and why do we get what we get. Like I say, telling the story behind those numbers. Are we okay to move on, or do you need another second? Okay.
female and the same.
You could put gender, right? So the distribution of income is the same for gender. It's not the same for the gender?
Okay, I just left it at same. But
For now, that's fine, but on the test, just make
Okay.
sure you do it. All right, are we ready to move on? Okay, let's do it. The next thing we need to actually do now is figure out that chi-square. But before we figure out that chi-square, let's talk about what those expected counts means. Those expected counts are what should happen if the null hypothesis is true. Which means if the distribution of incomes are actually the same, meaning there's no gender wage gap, we should get these numbers. And you'll notice that they are a little different compared to our observed. And the question is it like if I got a 97% on a test and you got a 95%? That's different, but it's not significantly different. So we're trying to see if it's so significantly different that we can prove there is a gender wage gap at HA. Okay, does that make sense? Okay, so I'm moving on to step 3. Step 3 is find that chi-square statistic, and I am going to give people values to do again just to save us some time. So our chi-square is still on the whiteboard. It's that observed minus your expected squared divided by your expected. There are times on the test where I will give you the chi-squared, so you don't have to go through the tedious work of finding it by hand. You just have to find the p-value and conclude. Trying to get my pen smaller, but oh well. Okay, so chi-squared is equal to our first observation, 109, minus our expected 158.4 squared over 158.4. 6 times we have to do this. Again, tedious. 365 minus 323.2 squared divided by 323.2. If you have a graphing calculator on the test in order to show your work, you can just put plus ... after you do a couple.
how many?
2 or 3. The next one, we have 26 minus the expected 18.4. Squared divided by 18.4 plus 192 minus 142.6 squared divided by 142.6 plus 249 minus 290.8 squared divided by 290.8. So nothing is changing how we're doing this chi-squared. Plus 9 minus 16.6 squared divided by 16.6. And again, to help us out, I'm going to assign some of you some numbers just so it goes a little quicker. And some of you, if you could like double check them, that would be great. Let's get Sarah M. Can you get these 2 red ones for me? Okay. Let's get James. Can you get the 2 green ones for me? And then blue. Janai, can you get the blue ones for me? Do you have a calculator, Janai? Okay, thank you. Remember, when you are typing these in your calculator, do parentheses first, hit enter, then square, hit enter, then divide, unless you're really savvy with your calculator, okay? If you're savvy with your calculator and you get it right every single time, do that. But if not, make sure you're doing your order of operations there. Does anyone have any questions about the chi-square right now? So nothing's changed on how we compute it. It's all about the interpretation. Who did I assign red to? Are you ready? Yeah. Okay, so Sarah had the red. Sarah, what's the first red term?
15.4.
15.4, thank you. Second red term?
5.
5.4, thank you. Janai, are you ready? Okay, the first green term, Janai. Oh, James, sorry. 3.13. So let's just say 3.1. 17.1, perfect. And then Janai, you were blue, I'm sorry. 6.0, okay. 3.5. Okay, and now I need you to add up the colored numbers, okay? Each individual chi-square component. Yep, so the difference between chi-square for independence versus homogeneity, there's no difference in the calculations. It's all about the interpretation, the telling the story. So the null and the alternative and the conclusion. And again, the difference, well, how am I supposed to know, is those words, are the distributions the same? And do I have 2+ samples? If I have 2+ samples, that's your surefire way I know I'm doing homogeneity. Two or more, yep. It will be 2 for you guys, but when you get into higher levels of stats, it could be more. All right, did anyone add it up? Did you get 50 something? 50.6, what did you guys get, those of you who did use the grapher? Did you get 50.6 as well, or did it by hand? 50.5. Okay, so about the same. Perfect, let's put 50.6. So our chi-square value is 50.6. We're almost done. The tedious piece is done. Your next step is you need to find your degrees of freedom. Your degrees of freedom are your rows minus 1 times your columns minus 1. If you've forgotten, I can write it on the board. Remember, what is that mistake I said watch out for? Don't count what in your rows and your columns. Don't count the totals in your columns or your rows. So how many rows do we have when you look at your problem?
2.
Yeah, we have 2 rows, male and female. And then we have what? 3 columns. So our degrees of freedom is equal to 2. Now that we have our degrees of freedom and our chi-squared value, we need to estimate our p-value using the chart. If you're using the graphing calculator, you'll see your p-value is a number times e to the negative 11. You can put approximately 0. If you don't have the grapher, you have to go to your chart. You go to 2 degrees of freedom. Practice using your chart now so you know how to use it. You're using your white chart, not your yellow chart. Does anyone need the white chart? Okay, when I go to degrees of freedom, 2, I go all the way across. What do you guys notice about your chart? What happens? We go off the chart, which means our p-value is less than 0.0005. Unless we have a graphing calculator or we use our computer, we don't know the actual p-value. We just know that it's very low. So remember this phrase when you conclude. When your p-value is low, reject the HO. P-value is low, reject the HO. The conclusion is the same for all significance testing. Whenever you have a null and an alternative, if you've forgotten, I have it here. And I used my math type for this, so it looks a little funny. So write this down if you need it. I'll leave it up here for a few minutes or a few seconds. Don't forget. If your p-value is less than alpha, this says I reject. The H naught, I have evidence for the HA. If your p-value is greater than alpha, we fail to reject H naught. We have no evidence for HA. I'll leave this up here for a little bit and then I'll put the actual conclusion down. That will work for every single one that we have a null and an alternative hypothesis for when you're finding a p-value. Now, we did with our t-values, okay, our t-scores, we did it a little bit differently. But if you're ever finding a p-value, this one is the way it will work for every single problem.
But you said at the beginning, like, we know it's this one when.
Oh, I'm sorry. So Lainey was asking, how do we know it's homogeneity? Is that what you're saying?
Yeah. Like,
Okay, how do we know it's homogeneity? The biggest key is you have 2 or more samples. And in the problem, when you read it, it says we interviewed 500 males and 450 females. You see the 2 there. If it was independence, they would say the word relationship, and then it would only be 1 sample. They'd say we interviewed 950 people, okay? And I'll talk more about that on Tuesday a little bit. I'll just give a little 10-minute spiel, if I can, about that. Let's actually put the real conclusion down in context, and you guys have made it. Good job. You are done with anything new in math for the rest of your high school career. Should we give a round of applause? Oh, that was kind of not the best round of applause, but it's okay. Lainey, did I answer your question or no? Oh, shoot. Okay. Get your conclusion down, and I'm going to go chat with Lainey because I didn't understand her question. Because our p-value is less than alpha, we reject the H naught. We have evidence that the distribution for gender and income levels is not the same. I'm going to stop taping. I'm going to hand out your work. You'll have a work day over tomorrow, and that's